Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends. In this video, we are going to study that what is cathode ray oscilloscope or CRO. So let us start with our topic. The cathode ray oscilloscope, which is also known as CRO, it is the most useful and versatile instrument which is used for the measurement, display and analysis of various types of waveforms and also other phenomena in electrical and electronic circuits. So we can say that CRO is basically a test instrument which helps an individual to plot a figure or to plot a signal versus time or another signal. So in CRO, a signal is plotted, okay, and we can analyze or measure the various phenomena, like we can measure the time interval, the amplitude using the CRO. So we can say that the most important use of CRO is the display, measurement and analysis of various types of waveforms and other phenomena, and it is the most important instrument which is used in the electrical and electronic circuits. Now CRO, it is basically an XY plotter, means it is going to plot a signal on the X and the Y axis. Now the signal which is plotted, that is the input signal, and this input signal is plotted either versus time or versus another signal. So on the XY plot, we will have on the X-axis, we will either have the time or another signal, and on the y-axis we will have the input signal. So CRO, we can say that it is basically an XY plotter. Now as it is an XY plotter, so we are going to use some pointer to plot that signal, okay. So in CRO, the plotter, or we can say the pointer which is used to plot the signal, or the stylus, it is a luminous spot. So the pointer which is plotting the input signal, that pointer or stylus, it is a luminous spot, and this luminous spot, it moves over the display area in response to the input signal. So whatever will be the value of the input signal, or we can say the instantaneous values of the input signals which are changing with time, that will be shown by the luminous spot. So this spot moves accordingly to the input signal, or we can say over the display area of the CRO, we are going to see, or we are going to see the input signal, or we are going to see the luminous spot moving according to the input signal. So here the stylus is a luminous spot. this luminous spot which is displaying the input signal, this luminous spot is produced by a beam of electrons which is striking a fluorescent screen. So when a beam of electrons which is having very high velocity at a very high speed, these electrons, they are going to strike a fluorescent screen, and due to the striking of the electrons, a luminous spot will be produced. Okay. Now, why the beam of electrons they are used for striking the fluorescent screen or for generating the luminous spot? Because the beam of electrons, they have a very low inertia effects associated with them, and due to the low inertia effects, these beam of electrons, they are going to produce the luminous spot. So due to the low inertia effects associated with the beam of electrons, such a beam of electrons is used for following the changes in the instantaneous values of the input signal. Now this input signal, it is varying at a very high speed with the time. So to follow the changes in the input signal, the beam of electrons is used. So whatever changes in the input signals are making, those changes will be reflected by the beam of electrons over the display area. Okay. Now, if we come to the normal form of CRO, that is cathode ray oscilloscope, it will consist of two inputs, horizontal input and vertical input. The horizontal input of the CRO, it is an internally generated voltage, and that voltage, it is going to move the luminous spot from left to right. Whereas the vertical input, it is the input signal which we want to display or measure, and that input is going to move the luminous spot up and down. So both these inputs, they are going to make the luminous spot move over the display area. Horizontal input, it will cause the luminous spot to move from left to right, and vertical input will cause the luminous spot to move from up to down. Now basically the CRO, they operates on the voltages. So the horizontal input and vertical input, they will be a type of voltages. So horizontal input, it is a voltage which is internally generated. And the type of this voltage, it is a ramp voltage. So we can say that horizontal input, it is a type of internally generated ramp voltage which is known as time base. And this horizontal input voltage, it is going to move the luminous spot from left to right. So horizontal input, it is making the movement of luminous spot in horizontal direction, whereas the vertical input, it is making the movement of the luminous spot in the vertical direction. So vertical input, it is also a type of voltage, and that is the voltage under investigation, or we can say the input voltage. So we can say the luminous spot, it is going to track the movement or the changes in the input voltage, and it is going to plot the input voltage with respect to time. If we want that, we will if we want to display two inputs or two signals on the display area of the CRO, then on one input we are going to apply one signal, and on another input we are going to supply the second input. So both the input signals, they will be displayed on the display area. Now if we see that how the CRO looks, what is that instrument? This is how the CRO looks, and this is the most common instrument which we use in our laboratories. You can see that there are various knobs on it, and this is the display area. Now when one of the input is a internally generated ramp input in ramp voltage, and another input is the input signal, then we are going to get a waveform. Okay, and this waveform, it shows the input signal which is plotted with respect to time. Now if we want that, we want to plot this input signal with respect to another signal, so the horizontal and the vertical inputs, they will be changed. So this is how the CRO, it displays the waveforms on its display area using the luminous spot. Now when the input voltage, it is changing very rapidly, or it is repeating itself at a very high speed, so the trace or the luminous spot, it is going to appear as stationary on the screen. So we will see that there are no changes in the input signal, because the input signal, it is changing or it is repeating itself at a very high speed, so that minute changes will not be caused in the luminous spot. It is not going to track that, and we will see the luminous spot to be stationary on the screen. So we can say that CRO, it provides us a means of visualizing the voltages, and if we want to measure any phenomena or any variables with respect to those input signal, we can do that with the help of the CRO. And that is why the CRO, it is used as a universal tool in the investigation of various types of signals in the electrical and electronic circuits. Now as we have seen that the CRO, it basically operates on the voltages. We have seen that the horizontal input and the vertical input both are a type of voltages. Now if we want that the CRO, it should also operate on the current and strain, all these other variables also. So what we will do, we are going to convert the current, strain and other variables into the voltages, and then we are going to apply it to the CRO. So CRO, they are operating on the voltages only, and we can analyze the current, strain, acceleration, pressure and other physical quantities also with the help of CRO by converting them into voltages with the help of transducers. So we can see that not only the voltages but all other quantities also, they can be analyzed or measured with the help of the CRO. So we can say that a wide variety of dynamic phenomena can be seen with the help of the cathode ray oscilloscope. So if we come to the uses of the CRO, that where this laboratory instrument CRO is used. So in the laboratories, CRO is not only used to investigate the different types of waveforms, but it is also used to measure the short time intervals, and also it can be used as a voltmeter to measure the potential difference. So CRO is not only displaying or it is not only used for visualizing the waveforms, but it also has other uses also for the measurement of like voltage, current, for frequency measurements, for the measurement of phase difference also CRO can be used. Now the conventional, if we come to the modern CROs, they are coming up with additional features also. Like the conventional CROs, they were basically used for the investigation of waveforms only, but now the modern CROs, they are coming with the additional features also, like multimeters, counters. So the use of the CRO has been expanded and its applications has increased. So if we come to the applications or uses of oscilloscopes, their use has been increased because they can be used, they can measure frequencies up to 16 hertz also. They can observe events as small as 20 hertz in durations. Also they are coming up with the additional features, and those features allow them to be used as the multimeters and counters also. And also they can be used to calculate the rise time, pulse width and the phase difference between two signals, because the oscilloscopes, we can apply two signals simultaneously. So if we want to measure the phase difference between those two signals, that can be done with the help of oscilloscopes also. Now if we come up to the types of oscilloscopes, there are various types like sampling oscilloscope, storage oscilloscopes, which are used for the high speed applications, and sampling oscilloscopes, which are used for capturing the transient responses. Also there are types like digital oscilloscope, analog oscilloscope. On the type of the signal, like if we are displaying an digital signal or an analog signal, there are two types, digital and analog oscilloscopes. Also there are dual trace oscilloscopes. So there are various types of oscilloscopes available in the laboratories. So in this video we studied that what is cathode ray oscilloscope, how it is used to display and measure and visualize the different types of waveforms, what are the various uses of it, and how it plots the signals on its display screen. So I hope that this topic, cathode ray oscilloscope, is clear to you. Thank you.